Hello, I'm very honored to be here today in Minsk, in Belarus. My name is Anna Kazakova Lindegren, and today I will tell you how to make sense of census. I will tell you about what a girl with an accounting degree is doing today at the PyCon conference. How did I become a chairwoman of PyCon Sweden? I will tell a little bit of the smartest city in the world, according to the competition from 2019. I will tell that every census lies and how to polygraph the census. I will explore a little bit about how why on earth will the air in Stockholm City accidentally go worse, and what can be the odd reasons about that, and the lessons that I learned working with this project. So about me. Right now I'm working in IBM as a data scientist, but I'm Russian originally, and I moved to Sweden in 2008. I had a dream to study in English language to the master degree in European University, and Sweden became this country that during that time was offering free of charge education for non-European Union citizens. So I had a prosperous career in marketing, but I changed it to being a nanny and moved to Sweden. In 2013, I graduated from Stockholm University with my master accounting and auditing, and 4 years later, I ended up as a data science consultant and CGT. So what did happen during these 4 years? I met this girl. Her name is Oksana Lindstrom, and we met in the swimming pool because I'm keen on swimming, and we opened two companies together. We opened a Stockholm International Swimming Club, where right now we have 250 members per year, and we opened the consulting company Kamishi, that at that time she was providing the software engineer consultancy, and I was providing my accounting services. So she is from Bauman University, and she got her master's in Gothenburg. So, and when we met, opened the consultancy company, she was trying to persuade me to switch to the software engineering, but I was not that much interested in about that. So she took me to the PyLadies. This is actually the picture of us sitting on coding. You can see my face wasn't very happy about that. But she continued persuading me, and to be honest, most of my clients, they were IT-related companies. I was accounted for PyCon Sweden, I was accounted for Pragma, it's international company. I was an auditor for TEDx Stockholm. So, and one day she persuaded me, giving me an example that actually you can code for a data science to analyze the data. So imagine that you have an airport company and you know that several airlines were particularly late this week and you need to invoice them. But you cannot open this data on Excel because data is too big. So how you will solve it? You need to invoice somebody. And as soon as she started talking to me on the money language, I naturally understood what she's meaning. And I say, this is something interesting. I can learn that. And this is how she persuaded me to move to the data science. At the same time, she was very supportive, but I met a lot of people who, even among my friends, who were saying that, hello, I'm writing code since I'm 15 and you are 31 years old. How on earth you will come to this field? And Oksana told that there is a place for everybody in the data field. You will be solving different problems. You don't need to compete. So her support brought me all the way here. She helped me to make a learning path. At that time, they were not having another degrees in Udacity or in DataCamp, there was not career tracks. But during my education in 2017, they actually begins being there. So I took several courses in R. I started with R and DataCamp, then I added SQL, mostly MySQL and SQLite. And then I naturally came to the Python, and Python was like the language that I feel kind of more organically about. And I stuck with this. And then I came back to the PyCon Sweden and say, you know, guys, now I'm not an accountant. Now I get the job at CGT. And they said, oh, if you want, you can come back, but work with us, with organizers. And because the PyCon Sweden is a non-profit organization in Sweden, so they just, we have election every year, and 2 years in a row they chose me as a chairwoman, and I'm proudly to say that we grew twice for these years that I was a chairwoman, so it's something to be happy about. And of course I added some statistical courses from Dalarna University. I took some social network analysis from Sweden University, and a data science is like a process. It's the job when you will never learning, depending on where you come from. So I come from business, communication, and statistics. So I was adding constantly the programming, and I love the data scientist Venn diagram because it's really show us who we are and where we come from. And I think that data science is so amazing that we don't need just to throw out our experience from the previous year. We just combine with a new experience, and that was make us the perfect data scientist. I would like to also to mention that I see the trends in Sweden right now about the data science profession. And usually people say that we have a lack of data scientists, but I noticed that in the job announcement, what they call a data scientist is not always a data scientist. It may be a data analyst, a data engineer, or the data scientist, the guy who understands every part of that and can manage the team. And I can see that right now we have more and more jobs coming for data engineers. And I think if you're coming from a programming, if you have a degree in software engineering or in computer science, or you have like multiple years in programming, then the data engineering is most recommended from my side for you to go to. And I think that in the near years, it will be better paid than just a normal data science job. Everybody migrate to cloud, so to use this opportunity. So GrowSmarter. So what is the GrowSmarter? GrowSmarter is one of the projects. It was the first project I was doing at IBM when I just started there. And it's a European Union project where 3 cities are involved. It's like Stockholm, Barcelona, and Cologne. On German, it's Köln. So the project is 4 years long project sponsored by European Union. And you can see the project team, you can see the scroll codes. If you would like to learn more about these projects, you can use them. And this project was divided on 3 areas of actions. It's low energy districts, it's integrated infrastructures, and sustainable urban mobility. This part of the area I was involved. And it's also nice to say that Stockholm in November 2019 won the prize of the smartest city in the world. It was like more than 450 competitors and nominees, and they got this prize because we were having this project for 4 years. And it's really nice as a data scientist to feel something tangible as a result of your job. I'm like so used that everything that I work with is NDA. I cannot even share with my family what I'm working with, and everything is secret. Data is not open source, but that was one of the projects that I'm proud to be a part of. It's huge, enormous team that were a part of that, and of course it's cool to see that. So census. So right now we will talk a little bit closer. What was that? And I will tell you about the sensors, the IoT sensors we have been working with. And I will just give a little bit like perception of the difficulties that you might meet working with the sensors. Well, sometimes if you come to the factory like Volvo trucks, you have like thousands of sensors, but they are all the same. It's not when you try to understand the urbanization of the city. So we had 30 plus sensors, and they were placed in a highly populated area in Stockholm. It calls Slakthuset. It's on the map, and it's populated by the people coming there to the work or shopping, or there they have like Globe and Quality Globe Hotel. This is the one of the biggest arenas that we have. Tele2 Arena is a football arena, and for great music events. Ericsson Globe is mostly for the music events. So it's a lot of population going there. So we had 10 vehicle sensors, they were cameras, and we had wild environmental sensors and 23 Wi-Fi people sensors. You can also see how they are located. So I will tell particularly about free spaces and bring you examples of how it's so difficult to work with the sensors. So imagine that we have 4 different types of cameras, and we have 1 environmental sensors, 1 audio sensor, and Wi-Fi sensors everywhere in these areas. So in area 1, for example, we have facility labs cameras. They are taking pictures of a license plate. So when they take a picture of the license plate, I can have a lot of data. I know the weight of the car. It's anonymized, of course, so I cannot see the real license plate when I get the data. So you can see the reg number. It looks like that because it's an anonymization. However, it's unique, so I can see this car, how the car was moving around there. And it's huge. It has 145 columns. And the data that is providing me is not all the data that I need, but it's coming from a cloud, and it's on Watson, and I'm taking this away already as a CSV file. And this is at the place number 1. Another type is a Wi-Fi sensors that coming in this particular format. It's also a CSV file, also coming from a cloud, and here I just see the MAC address. I don't see anything else. I just see when this MAC address was registered. So the whole sensor is just giving me that the unique person was here at that moment of the time. Then I have a Venocean camera that originally is providing me something as non-SQL data as a JSON file that I need to take this very nasty JSON file and create it in a CSV file, so I will be able to work further with an analysis in my notebooks. And here we have another classification. So if the facility labs camera that is taking the license plates, it's ignoring motorcycles, it's ignoring people because it's just take the license plates. So it's basically give me trucks and cars. And that's all what I know. Here I know what type of the car it was. Was it a truck? Was it a small car? Was it a motorcycle? Was it a person? Was this person walking? Was this person cycling? So I get more measurements. Bosch cameras are giving me probability. So they are giving me totally different type of like class type index. It's like Bosch camera is connected to an MS MySQL. So basically it's a database with the relation tables that is giving me probability also, and it's enormous. So basically I need to perform first code in SQL, sort out the higher probability per every unique object, and then only to take this to my notebook, because otherwise the data is just too much. And again, the problem is I need to translate this classification of the objects to be able to compare that with this or with this. But I need to make sense of all these senses. Because I need to test them. What senses is telling true? What senses is lies to us? What is more accurate? You see, I still emotions about that. And then it's like you see in the blue circles, you see the objects. It's like I'm trying to say that it shows the probability of the same object. So in here, the algorithm was that when the object is moving, camera is taking multiple shots, and every this shot, it's give a probability of what type of class index this object belongs to. And in the third place that I show you in the map, there is also environmental sensor. And here is a picture. So the white up is a Bosch camera, this one. And the down, these three boxes, this is environmental sensors that is showing me NO2, PM1, PM10, and PM2.5. This is different size of the particles that are pollution in the area. And depending on the size of the particles, we know what diseases does these particles like cause. So, analysis. First of analysis, the first difficulty was to choose the appropriate time interval. In Europe, we have something that calls GDPR. So basically, it took almost 3 years for the project to get all papers done and registered, sign all the contracts that we can place these cameras and start getting data. Even though we get anonymized data, it still took us so much time just to help our partners to come on time with that. So you can see, for example, at the Vinocean weekly data, they changed the intervals, how often the camera was like. So you see the difference in the amounts of the data, and when you look at this, I can understand that I can just take week 43, 44 on 35 for comparison. Everything else I just need to throw away, because that will be not comparable between itself, because it doesn't look stable. Here is, for example, the Vinocean camera and Bosch cameras that are situated on a place number 2, and they just situated on the same pole. So basically, these are the two cameras that looking in the same direction. And look how different amount of objects do they register. However, if I look at the correlation and the trends, I can see that there is a highly correlation, like with, for example, Vinocean cars and Bosch cars. So I see that every Sunday the amount of cars in this area goes down, and every Monday they go back up. And we have this correlation. So if I want to say what cameras show it's right and what cameras show it's not right, I don't know. I don't have any mechanism to divide this and to decide about that. But if I would like to understand what's going on in their area in overall, then yes, I can use it, because they are both kind of showing the same. And then we look at the Wi-Fi Census. And what is so difficult with them, you can see the difference on a slide from the left, the difference between the amount of objects that the Wi-Fi Census is registering and the amount of objects that Bosch camera and Vinocean camera has been registering. And the problem is that Wi-Fi sensors, even though in the beginning they have been claimed that it's only our mobile phones and people and cyclists who are moving in this area will be detected. But when I look, for example, for this specific address from the right for the Wi-Fi at the Wi-Fi Census 108, I see that like minimum 40 pings during the night per hour. This unique address was sending the signals. So I understand it couldn't be a person that during the night just going back and forth, that this sensor is like trying to be detected. And when I do this analysis, so first I needed to find out what are the statistic devices are there, how, and like take away from all the data, all the statistics devices, so to be able to be closer in comparison to the cameras. But again, you can see that there are some correlations in the trends between Wi-Fi sensors and cameras. Environmental sensors are, like here I just give you an example about how do they look like if I try to visualize them. And there is, the topest name is PM1. there are a correlation between PM1 and PM2.5, but PM10 is like living itself, its world, its life. So I'm trying to see how the sensors. So my like attempt to working with the sensors was to explain. Okay, so we see the clear peaks, for example, at PM 2.5. This is one of the sensors that detect they're very small particles that is like causes the hardest disease that we can get, inflammatory disease, deathful disease. So, and I see that this is changing. So, okay, so why it's changing? And you can see at this pole, I have environmental sensors and I have a camera. So, okay, so I think that maybe it's a dirty cars that giving us this inflation, but no, it's not cars. If you look at the vehicles data from the camera that is based there, there is no correlation between that. It looks like it's a people who make the city dirty, specifically on Friday nights and Saturday nights. So I called the Stockholm City and asked, okay guys, tell me, when do you clean the streets? Because in Stockholm, we once per week, they are cleaning the streets, and the machine that is cleaning the streets is getting all this, dust up. So I think maybe it's detecting that. Now I called them. They say between October and February, we are not cleaning the streets because the streets are with the stones. Because we don't have salt on the streets. When it's slippery, we have little stones. So that's why the streets are not cleaning them. Okay, maybe it's a factory production. It should be like some reason. No, there is no factory. There is no lab that is like polluting the area during the night, the secret lab. No, there is nothing. Okay, maybe it's trucks, because this area is like Slaghusområde, where is a lot of trucks. Yeah, but all trucks are coming on the night of Sunday. So it couldn't be trucks, because we know there is no correlation with the vehicles. So what's going on? There are 2 nightclubs there. And you can see when it's like pink sensors on the top, this is exactly the pole where the sensors are setting. And if you look here, you can see that over the sensor, there is a wall. It's kind of not an open area. There is a roof over this. So this is people standing in a line, standing and smoking. And basically P2.5 is also a smoke detector. That is when you're smoking. So basically every Friday and Saturday between 10 p.m. and 3 a.m. or 5 a.m., the traffic of people is up, the air is down. And we know that probably it's not the best idea to put an environmental sensors under the roof and next to their nightclubs in Sweden. But it was funny because I also was having a database, I was having a web crawler with events. So I was trying to correlate events and changing of the traffic, but this area is so popular, so with different events. And there is a football matches, but all matches, they are like closing like 11, the latest, usually 10. But the traffic of people, this correlation during Sunday and Saturdays were during the nighttime. So this is how I figure out that there are 2 clubs that are not really advertising themselves. So people partying make the air dirty. Another one, Wi-Fi sensors. The odd findings working with Wi-Fi sensors was, as I told you, there is this statistic devices that are sending the signals, and Wi-Fi sensors has a big plus that they are cheap. They are cheap and they anonymize. So we don't need to wait for this regulation just to place another sensor. And the 4 students who were taking their internship, and IBM wrote 2 master dissertations about how to use. They were working specifically with the Wi-Fi census, and because we had 23 of them, they could, depending on the speed, for example, realize where this person go from this sensor to this sensor. So basically, in all possible roads and turns in this area, the sensors were. But suddenly people start disappearing. So just we cannot find person. So it's ended up and detected at one sensor, but then we cannot find them in another sensor. And it was like, okay, what's going on? So they were using Bayesian approach there. And it's like, we know that it's working, but somehow it's like, we start having disappearing people. Well, of course, people didn't start disappearing. Somewhere during 2019, the macro randomization addresses that's being much better, especially on the Android phone. So, and this is how we couldn't find the people, because their devices, as soon they're turning like one Wi-Fi sensor, another Wi-Fi sensor was sending us a totally different, unique MAC address, and we couldn't follow them during the census. Oh, we still could follow some, but you know, we were losing people. So it was also funny. I also didn't sleep several days trying to, like, with the case with the nightclub, I tried to realize what's going on. It's like, how it's happened, but well, finally we have this at the better point. So what are the lessons learned? Well, everybody lies, even sensors, and you can polygraph the sensor. And this is what is very important to know, that every sensor that I showed you, if you remember, they had a timestamp. And because we didn't have the same type of the sensors, they all have different time zone in their timestamp. So it's very important to you to understand at what zone the sensors is situated, and then standardize them to be able to compare their data. Then it's a cohesiveness of data to understand and translate from one sensor's categorization to another one. Check the battery level. Oh, this was very fun with the environmental sensors. Like suddenly we had less data and we couldn't understand why, but then, oi, its battery level went down. It's probably time to change the battery. Calibration. Oh, this is huge. If you work with the sensors, that is cameras, you need to check calibration, because somehow it's just went off sometimes. And calibration is important because if the algorithm that the camera is using is depending on the size of the object is detecting, for example, either this normal car or a truck, then the calibration is the key. So, and when you calibrate the camera, you kind of measure all the stops, all the objects that are not movable at the camera side. And if something went wrong, then in our case, it was all small cars were detected as trucks. So one day we just had too many trucks, and it's like, okay, it's like, it looks like a war or something. Where they come from? And decide for yourself if the missing data is better than the lack of the data. It's like, here is an example of how uncohesive was the data and how I couldn't really trust the data, and the green zone is the only data that I can trust. So I needed to decide if I would like to perform analysis with lack of the data, or it's better to just throw this away. So yeah, sometimes life just changes. So remember about that, it can also applies for the cameras. Notebooks. So notebooks is the typical a tool that the data scientists are working with, and especially with the sensors. Like, I specifically don't go to the pie chart because I need to visualize basically all the data that I can see directly. And of course, the notebook is like a simpler choice for me, but at the same time, it's become so long. Just imagine that I have 10 different sensors of vehicles and then 23 of people and then one environmental and another one. It's just messy. However, if you do the table of context and collapse the headings, you can keep your notebook structured. You don't feel that you're scrolling 100 pages just to the area where you have been working recently. So don't underestimate the content structure of your notebook. And the notebook can be messy, right? So use the modular approach. So as soon as you have a stable code that you can see that repeatedly, turn it to the function and move it to the module. Jupyter also has a retrolation extension that reloads important models. So use this auto reload to reload the data. Hinterland is one of the shortcuts, so we're just basically like auto completion in the Jupyter. So you can Google this word, and it's really helpful when you just not need to write all the comment, all the name, but just click the tab and it's get. Auto pep is something that you can install to the notebook as a widget. So basically you just choose the parts of the code that you would like to auto-pep and just click the button. And a PyTest for testing inside the notebooks if you have something to test there. So I think that was all for me, and just like the last what I would like to add is I start talking with my friend who support me so much. So if you next to yourself see the person in their 50s or 40s or 30s who is deciding to change the job, just be that support that she was for me, because my life did change for the best. So you can be also this mentor. Thank you.
Thank you.